So in this example, I am going to do, they wrote theirs as the function. Oh, and then they want you to evaluate. OK. So you know what? I'll just do a whole example of this. They're asking you to do f of g of 3, right? What I'd like you guys to understand is I'm also going to do. Oh, it is? All right, so let's do f of g of x, and then I'll show you how to evaluate anyways, though. So please remember, when you have fog, or f of g of x, what I'm asking you guys to do is do f of g of x. Dang it, let me color code these. I think it just makes it. All I'm asking you guys to do is do f of g of x. That means for whatever my input variable, I'm now going to plug in g of x. And just to go over this one more time, if I had h of x equals 2x minus 1, and if I said, what is h of 0, where would you put the 0 in for? X, OK. So you do 2 times 0 minus 1. Everybody's OK with that, right? You guys had a quiz on that. Plugged it in, right? I think everybody did pretty good on that. Well, what if I said h of g of x? What do you now put in for x? The g of x. So now it's 2 times g of x. Well, 2 times g of x, what the heck is that? Well, what does g of x represent? G of x represents x minus 1. So that's exactly what this is saying. I'm going to plug in g of x in for the input variable. If you guys remember that focus lesson, we talked about the input. G of x is now the input. And g of x represents x minus 1. So what this looks like is 3 times g of x, which is x minus 1, plus 2. Do you guys agree with me? Instead of writing g of x, I'm writing what g of x is equal to, which is x minus 1. Does everybody see that? Does that make sense? Anybody have any questions? Then you apply distributive property. And you have 3x minus 3 plus 2, 3x minus 1. Now, if somebody was going to describe this graph, what type of what would that graph look like? Quadratic, a cubic function? What would this create? A linear, a line, right? Now, let's pretend you don't even know what the line looks like. But we know what we do remember graphing lines, right? Ladies and gentlemen, is there any discontinuities in this?
No.
No. Is there any reason why we can't plug in any number in for x and multiply it by 3 and subtract it by 1? Every real number we can possibly think of, you can multiply by 3 and subtract by 1. So the reason why is therefore your domain is negative infinity to infinity. There's no discontinuities. There's no reason why you can't plug in any number in for x, right? There's no number that makes it 0, and there's no number that you're taking the square root of a negative number. Yes? You might also see it like all real numbers. And you could also see it like this. Negative infinity is less than or equal to x, which is less than or equal to infinity. Those are 3 different representations. But I'm focusing on interval notation in this class. But not to say, though,